There we go. Okay. So I'm going to just go over a couple topics that I think are necessary to go over. And if anyone has any questions, you can feel free to ask. You can type it in the group chat, or you can just talk. Doesn't matter to me. I have the chat open. If you want to ask me something just privately on the chat, then maybe wait till like after, and like you can email me, or we can, talk privately, because when I post this, then like the chat groups are all like available for everyone to see. So if you have something private that you need to talk about, we can just talk about that after. Okay. All right. Does anyone have like any questions they want to start with, or you want me just to start looking at some of the review stuff?
When do you think the extra credit quiz will be graded?
It should be graded immediately. So the computer grades it. If
Oh, because my computer didn't grade mine.
let me look at it. It might not show you. I don't know if it shows the grade, but it might not show you, like the solutions, like where you can go back and review it, just because it's out there.
Okay.
To me, they're great either, Professor.
It didn't grade yours. Okay, so
Yeah.
maybe I just didn't have it set up properly. Oh, you know why? Because I don't have it. It's going to be extra points. Yeah. So what I will do, I got to think about how I'm going to do this, because I normally would just hand back papers, right?
Mhm.
So, I will probably, let's see. This is due today, right? No. When is this due? I have April 29th. So is that true? Is that what I have? I have it on here, April 29th. So that's Wednesday. Is that what I told you guys? I thought I had it for today. But anyways, if you've already completed the assignment, I can like email you.
Okay.
Or something. But what I'll do is when it's all done, like, and we've reached the due date, I will post the feedback if I can.
Okay.
Saying, hopefully you can go in and review it. And then you'll see on your lowest exam score, it should go up by that many points. But I can email people and let you know how many points you have. Then that way you kind of have an idea of what's going on.
All right. Sounds good.
All right. That's a good question. Any other questions? There doesn't have to be. I'm just.
So then is the final gonna be mostly based on the hypothesis testing? Like, is that gonna be a big portion?
It's not necessarily a big portion, but you can expect a full hypothesis question on there.
Okay.
So one of the questions on part 2 will be like the hypothesis test. So similar to what you've seen last week and on the extra credit, where it's just the problem and it's like a blank page, and I just tell you to do the full hypothesis test. Yep. So
Right.
you can expect that.
All right. Sounds good.
Careful. Okay. So that will be on there. But there's a lot of topics that were already covered on exam 1 and exam 2. So those are good resources if you have those still, or if you can find them, you could dig them out. Maybe some people threw them out. That's all right too. But I feel like the review gives like a good overview of the class and all the topics. I set my multiple choice up throughout the semester, so it's similar to the final exam. So I don't want, like, that's why I do multiple choice to begin with. So you guys are prepared for part 1. So although I don't make part 1 myself, I do review it, and I do you know, give suggestions if there's something I don't like. But just so you know, the questions should be similar to like what you're used to. For maybe the wording isn't, that's what makes it harder, is the wording isn't how I would word things necessarily, because it's not me writing it. But you know, like the reviews have a little bit different wording, that kind of thing. So I feel like that I just feel like all of the reviews and the past exams give you really good idea what's going to go on the multiple choice part. So I feel like, you know, you should be pretty prepared for that. It's just what makes it hard is it's not me writing it, and it's the material for the whole semester, right? So that's what makes it so difficult. And then plus you guys are studying for all other exams too. So it's just a lot. So what I did was, I think the multiple choices, I think I told you it was gonna be plus or minus 20 questions. I think right now it's 17. That can change. And then part 2, I made part 2, but I may cut it down a little. So I'm trying to make sure everyone has enough time and everyone doesn't feel rushed on the exam overall. So yes, we have 2.5 hours, and you will be allowed to use the first hour for the multiple choice. So it is timed, but I mean, an hour is a long time, right? Because if I give you like 9 questions on multiple choice, I tell you to try to do it in like 10, 15 minutes, right? So I feel like you should be all right with that. The hour is like longer than what you would usually get. If you were taking it in person, they would give you 35 minutes to do 20 questions. So we're just lengthening the time. So if there's any technical issues or anything, then it's not going to hinder someone's grade. And we know, like, you guys are all under different circumstances, you know, where you are, who's around you, the distractions, all that stuff. So we're just trying to lighten up a little bit so everyone doesn't have like all that extra pressure, because we already know you're under pressure as it is. So and the part 2, I just want to make sure you have enough time to complete it. I don't want people to feel stressed. So I don't want to say I have 100% complete, like I do, but I think I might want to take a few things out or lighten up a little bit. Okay, so that's about the exam. Any questions about what to expect, like on the exam, you know, like just taking the exam or anything? It should be the same thing as exam 2, where we took the multiple choice under the quizzing tool. And then once you completed that, then you were able to start and open the Word doc for part 2, and you just typed it in. It's fine if you handwrite and you do it as like a PDF, but in order for me to grade it, you have to type at least 20 words. So that's why I prefer you just to use it as a Word doc and type. Then there's no difficulties with that. I just don't want to have a problem, especially when it comes to the final exam. Okay. You guys are allowed a cheat sheet. So I allow you a full page, one-sided, 8.5 by 11. I will ask you to submit it like I did for exam 2, like in a separate Dropbox, just so we have it. And you have no restrictions on that. So if you have trouble picking out how to tell if something is numerical data, then you can write that down. If you have trouble with remembering all the steps of the hypothesis test because it's so new and there's so much going on, write it down. So I don't want you to feel like you're limited. So if you have exam 1 and exam 2, some people take those cheat sheets that they made, and they take stuff that they know they had trouble with and they put it on the final exam cheat sheet, and then they just leave off stuff that they, you know, really didn't need. So I'm glad we had the practice of the cheat sheet from the first 2 exams, so we're kind of prepared and have, you know, just have an idea of like what we've needed, what we haven't needed in the past.
Professor,
Yes.
sorry, for you said PDF, you need the 20-min words?
So yours was fine. However, you submitted your exam too. It wasn't a problem.
Okay, like, is that just for each question you mean, or like?
No, it's just like on the entire document.
Oh, okay.
So I don't know whatever you did. It was fine. I think everyone else submitted a Word doc.
Okay.
Yeah,
All right.
yours was fine. So whatever you did for exam 2 was fine.
Okay, thank you.
Okay, yep. Yep. And you guys will need your graphing calculators. So if you don't have one and maybe you're borrowing someone's before, you're borrowing from the library before, you can just search in the App Store for like a TI-84 graphing calculator or something, maybe one like you were using before. You can find a free app, and I don't care, just use that then. I'd rather you have something to use and know how to use it than not have anything, because you will need it. It's needed. It's not just a suggestion or it's allowed. It's needed, right? Like, you're not going to be able to calculate R and R squared and standard deviation with the time given by hand. So you're going to need that. Okay, so just keep that in mind too. Okay. And I will do the same thing as exam 2. I will post an integrity statement saying that you are being honest and you're taking the exam alone and using your own thoughts on the exam and not someone else's. You're not using like your book and your notes, just the cheat sheet and the calculator given. Okay, so those are the things you can expect. For the exam, we're going to do it for the same time that everyone else is taking our exam, since it does have a core. So that's the Friday at 4:15 to 6:45 time slot. If you have an issue with that, you need to contact me ahead of time. So I'm not going to be giving makeups on this exam if you come to me and say, oh, I missed it yesterday, right? So make sure you make arrangements ahead of time for that. Let me just check where our class is at on their evaluations, and then I'll start going over some material real quick, because I know a lot of people were interested in that. I have to log in. They send me like an email once in a while telling me what it is. Then I have to log in. So for our class, we have, it looks like maybe, no, it looks like the same thing as before. So we're at 76%. I think that's what I looked at it yesterday. So so let's see. Oh, so we need one more person to reach the 80%. So if one more person, if you guys haven't filled out your evaluation, do it so I can give you extra points on your grade. And oops, that's not right. And 5 people to get to the 90%. So if you didn't do it, I really would appreciate if you would do them. I really do read the feedback and I try to improve the course as much as I can. My teaching and everything. Okay, so I do appreciate that. All right, so enough about that. I will post an update a little bit later on that too, under the announcements tab where I've been posting them. Okay, so I'm going to just look at the multiple choice part of the review first, just to go over a couple things, maybe things that I think are helpful for us and that kind of thing. So when we're looking, I think this is the same. I didn't even look to see if this is the same. This is the one I had. I don't even know if this is the same review. I hope it is. Maybe I should double check this before I start saying that. Sorry. I was just thinking, oh, this is the same one, but maybe it's not. I've got 2 computers, that's why I'm looking off to the side. So I'm using a different computer to look this up real quick. So I'm just gonna look at the multiple choice quickly. And then, of course, if you have any questions, I think it's the same. I think it's the same review. Sometimes I change like little questions or little things in the question, but all right. So when we read the question 1, sometimes people don't know when we're looking for spread, if we're looking for standard error or standard deviation. So it all depends on what we're talking about. If we're just talking about the normal curve, that's just standard deviation. And that was like chapter 7. Anything after that, so sampling distributions, which was chapter 8, that's when we first introduced standard error. So it's that new calculation of spread, because we're not just looking at individual values anymore. So we have a different way of calculating spread. So that's when you're looking at numerical data and you're going to change to standard error is chapter 8, chapter 9, chapter 10. So anything other than just the normal curve of the data values. So if you're looking at sampling distributions, even if you're looking at like the standard normal, right, it's different. And then when you get into hypothesis testing and confidence intervals, that's my standard error. So that's my standard deviation, S, divided by the square root of n. Okay, so as you can see, like on the review, I don't actually ask you to do the calculation. I just show the numbers plugged into the calculation. That's the kind of thing you can expect. Okay, and I've done that on other exams as well, because I'm not allowing calculators in that part. The question 2 is about the empirical rule. I think most of us have that under our belts. I hope we do, because we kind of keep referring back to it. If you've noticed throughout the semester, it's like we learned that back in chapter 3, and then we keep referring back to it. So just wants to know what percentage of observations are approximately normal within 2 standard deviations. So that's the 95%. So for number 3, it's just the interpretation of the slope, right? So for each increase, a unit increase in x, my y will also increase or decrease by that slope amount. So that's, I don't think that's anything strange. Now, sometimes people get a little tripped up, like on a question like number 4, where I give you 2 box plots, and you have to pull out information about the 2, comparing the 2 box plots. So remember, what we're always looking at is like shape, center, and spread, right? Anytime we're looking at distribution, we keep going back to those 3 things. So on this one, it wants to know what is true. So it's not like I can look at the graph and say, well, I know this. I have to look at the options and then look to see if they're true. So like data A has a larger median. So remember, the median is the middle line in my box plot. And that's false because it's less than, right? It's to the left. So that's not true. Data A has a larger spread. That is false as well, because the box, right? So when we're looking at the spread of a box plot, we're looking at IQR, and that is the width of the actual box. So that's false. So the answer is D, neither A or B. Okay. Okay, I know this one. Number 5, I know when I have this review in class, a lot of people have questions on 5. So Dan and Rita are each estimating the same population mean. So I'm looking at numerical data. Dan's confidence interval is based on a random sample of n equals 50, and Rita's is based on an n is 200. How would you expect their confidence intervals to compare? So I want to know, is someone's wider? Are they the same? And remember what happens in my calculation when n increases. Just in general, without even thinking about the calculation, first of all, you could say, well, as n increases, my spread gets smaller to have a better idea of what's going on, right? I'm getting a bigger sample. And also what happens in the calculation is s divided by the square root of n. So if n is in the denominator and it's larger, then my entire standard error, which is my spread, will decrease. So it's going to make my confidence interval smaller for a larger n. So here is where it's D, where Dan's, because his is only a size of 50, is wider. Okay, so I know we get a lot of questions on that. Okay. All right, I'm going to mute for 1 second because I just have to check to see where Colin is because he's quiet. So give me 1 second. Okay, sorry about that. He was really being way too quiet, and I was afraid he like left the house. And those of you that met him, he's only 6. He can't do that. All right, so I'm going to move on with this multiple choice. Okay, so if you get a question like number 6 where it's saying, oh, here's a confidence interval, what's the point estimate? Remember, my point estimate is the center of my confidence interval. So it's the number right in between 52 and 66. And if you look at all your options, there's only one number. So if you can't even calculate the midpoint in your head on your own because you're under too much stress during the exam, I get it. Just look, there's only one option here that is in the middle, okay, in between the two numbers in the confidence interval. And just remember, the point estimate of a confidence interval is always right in the center. The confidence interval is built around the point estimate. The point estimate is my X bar or my P gap. Okay. Oh, number 7, we won't do. We did not cover that. I didn't cover type 1 and type 2 errors because it's something we don't have to cover. It's like a little extra thing. So we'll ignore question number 7 on here. Sorry, I didn't delete that. Didn't notice that. With the probability stuff, remember, like I said, you don't have to show a formula. You could just do the shading, or you can do the formulas. Some people just prefer formulas. I always preferred formulas. And then once I started using the tables, I just really like the tables. So it really doesn't matter to me. I'm not that picky about it. If you can get the answer and understand, I'm good with either way. So you just have to pay attention to the wording. So in a probability problem, you have to see, is it an and, is it an or is it like a given? So remember, the given is the tricky one where it's the restriction, right? So that's where you're going to outline your restriction and shade your interest, where the and is the overlap. And then or contains both. So it could be either this option or it could be the other option. So the or has a larger amount and has a smaller amount, and then a given has a smaller amount, and it's out, like the total is a smaller amount. So anyways, in this one, the answer is D. It's 700 out of 910. So we want to know if randomly select someone, what is the probability of a person who is female or, so right there, or, I know it's going to be a larger number in my denominator, not larger than not larger than the denominator, it's just going to be larger than if it was an and, like it's going to be a big amount, or has not experienced specific food cravings. So that's where I'm going to shade in my whole female column, and I'm going to shade in the entire column of food cravings. But the key is that you only count each number once that's being shaded. So I don't want to double count the 70. Okay. If you were doing the formulas, you would take the 550, the female column, plus the 220, which is the cravings, and then you would subtract out the 70 because it was double counted if you did the formulas. Okay. Number 9 is just showing you an NPP. Now this is on Minitab. This is the software I use. If you move on to Stat 2 with me, that's the software I use. There's a couple other professors that use this software as well. That's the NPP on that software instead of our calculators. I know it has a lot more information you need. All you need to say is that if it looks fairly linear, then we can assume normality. And that's what we're looking at for option B on here. Okay. So on number 10, we're looking at a hypothesis test, and we want to know what is the unknown parameter. So this goes back to my population step, and it's the third part in that population step, which is the unknowns. So for the unknown is either going to be P or mu. So depending on what type of data I have. Okay. So P is a proportion, that's categorical data. That means someone's answered yes or no to a question. Either they agree or they disagree. Either they fit in the category or they don't fit in the category, right? Numerical is like, well, what shoe size are you? What's your GPA? How far are you from home, right? It's like a number, it's a value, and it's going to vary a bunch from person to person to person, right? Where the categorical, it's a whole bunch of people answered yes and a whole bunch of people answered no, kind of thing, all right? That's how I know if it's proportions or mean. So here we want to convince others that more than 40%. So right away I see 40%. I'm thinking proportions. I'm thinking categorical data right away. Of RIT students support a pass-fail grade option. So right there, I know it's either they agree or they disagree, right? This is actually a really good topic right now because that's what we're doing. A lot of students are going for the pass-fail grade option. I don't know if a lot. I have a few students. I've already mentioned it. So here I'm looking at the population proportion of RIT students who support a pass-fail grade option. That's what my interest is. That's my hypothesis. So that's part or answer D. So you'll notice, like when I said it, I said the population proportion because that's exactly how I'd write it. But look, that just means all, right? Population, or someone might say the word true. it means all of it. It's not just the people in the sample. So I want you to see, it says proportion of all RIT students. So all is already included there. Okay. Any questions so far on some of the stuff I've gone over? I feel like I've gone through every question because I feel like they're all so important. Okay. Feel free to stop me, or ask if you have any questions. The confidence interval in number 11, it gives me the confidence interval. Okay, so 95% confidence interval is 57 plus or minus 4%. Okay, so we're 95% confident that 95% of all graduates have that. So that would mean that 95 is inside my CI, so A is not true. The next one is 95% confident that between 53 and 61. And that is true because that is my CI. So that's a good interpretation. So B, I like B. I'm going to continue to read through them because I want to make sure that that truly is the one I want. C says 95% confident that less than 57. No, because 57 is my point estimate, so it means half of them are less and half of them are more. So no, in order for a less than statement to be true, my entire CI would have to be less than that number. So the entire CI would have to be less than 57 for that to be true. It's not. It's only half of them. Does that make sense? I hope. The other one said 95% confident that 57% of all the RIT had this. So let me go back to this one, and then 95% confident that 4%. So no. And the reason why I say I want to go back to D, because we're 95% confident that 57%, which that is in my CI of all RIT had, so it could be D. I mean, I must be missing a word there because I really could have D as my answer. We're 95%, unless it says, yeah, because it just says which statement is consistent with the CI results. We're 95% confident that 57% of all RIT, it could be D. Like D could be the answer. I need to fix that. I really need it to say more than or something like that. So in order for a statement to be true, for a CI, if it says it is something, just that number has to be inside the CI. If it says it's less than, the entire CI must be less than. Or if it says greater than or more than, the entire CI must be more than that amount. So it must be true for every number inside that CI. So D, actually, I really should fix that. It could have been D. But I have B down for my answers, that we're confident that it's between those two numbers. Because we are. That's my interpretation. For some reason, number 12 seems to give students some trouble, and I think it's because we haven't looked at histograms in a while, and we kind of forget. So I just want you to keep in mind, a positive skew means a right skewed is letter C. It's letter C, right? So that just means that I have more values trailing to the right. Okay, if it was left skewed, it would be B, which is all these values left of my center, and they're trailing to the left. Okay, so this answer is C. And I think we just kind of forget because it's been such a long time, like since chapter 2, like week 1 or week 2 since we looked at these things. And I know we looked at them a little bit since then, but then we kind of get away from them. It's been a while. All right. Oh, number 13 is a good question. I see this kind of thing pop up a lot where we have a 95% confidence interval, 58 to 72, and I want to know what interval could represent a 99% interval. So what I want you to recognize is that I'm going for a 95% confidence up to a 99. And when I increase confidence, I'm increasing the width of my interval. So my number on the left, the 58, should be smaller. And the number on the right, my 72, should be larger because that would be making it wider. My point estimate's not changing, so my center's still the same. So they both should be getting, like the lower should be getting smaller and the upper should be getting larger. So the answer is B. Okay, if it was going the other way around, maybe from 95 down to 90, I would look for the interval to become smaller and narrower. So meaning my lower bound would increase and my upper bound would decrease. Okay, any questions on that stuff so far, guys? No? Okay. Number 14 is kind of a weird question, but the answer is C, a statistic. So I've mentioned this a few times in the video. Statistic is just some information from my sample. A parameter is information about my population. So that's really, I feel like, the only one you're really going to see here in the review that's really like a vocab kind of word, like a vocab kind of question, you know? And 15, we're talking about hypothesis test. I don't normally get questions on this one. I think most people get this. So if the sample has a probability of 0.04, which statement is correct conclusion for the test? The sample provides sufficient evidence to conclude that mu is less than 70 is the answer, A, right? Because my goal matches my HA, and my HA is right there in the statement. And if my p-value is less than 0.05, then I am showing evidence and support for that goal. Okay.
So for those,
Yeah.
you're okay with us using the one prop p-test and the t-test, right, in the calculator?
Yes, you can
Okay.
use the calculator for your result step. Yep, you don't have to do it, you know, each item by each item. You may use your calculators. It's completely fine. Yeah.
All right.
Good. Thank you. I don't like 16. I'm going to tell you. I don't even know if it's on yours. I'm going to look because I don't like it and I may have taken it off. No, I didn't take it off. I don't like it because when we start talking about confidence intervals, we say that it's not a chance, it's not a probability, and then the answer is, the question asks about a chance. So I don't like it. But it is my level of confidence is the chance that it's going to capture that population proportion or population mean. I don't like the wording. I need to get rid of this word chance because it bothers me because we don't want to talk about it as a probability, and that's what we think of when we say chance. And we've been studying probability in the past. We think about probability. So I don't like that question, to tell you the truth. I need to I'm going to star it, and I circled it. I'm hoping I remember for next semester to take that out. Again, 17, we're going to ignore. That's type 1 or type 2 errors. We didn't cover that topic. That's one of the topics I cut out, which we don't need. You don't need it to move on to Stat 2. We don't need it here. And other professors also cut that out, just so you know. That you're consistent with other Stat 1 classes, okay? Oh, I like 18. Again, it's the histogram thing. The reason why I like this is because it just brings back like old memories, and it just brings it back to us, right? Because we haven't looked at this stuff. And in this, I want to know the histogram, would you expect the mean to be smaller than the median, right? So in order to know that, and we're just looking at shape, I have to know what happens to my mean with the different shapes. Remember, average. Mean is sensitive to outliers. If something is sensitive to outliers, it means that a number that's far away is going to pull it. So when I have something that's skewed right or skewed left, it's going to pull my mean with that skew. So if I look at A, I have a skewed right distribution. The median's always right in the middle, but my mean will be pulled to the right. And if something's to the right, it means it's larger. So it's not the skewed right, it's going to be the skewed left. So it's going to be answer D. And just visualize the median right in the middle. And with that skew, with all those small numbers, my average is going to be pulled down. So think about it. If you take a whole bunch of quizzes and you bomb them, right, your average gets pulled down really quick. Okay? So think about it in that way. The C, which is the symmetric, that's our normal curve. That's what we are studying a lot, right now. That's where the mean is equal to the median, or they're really close to one another. Okay? Same thing happens for symmetric, and that's B. We just don't look at symmetric ever. Okay? All right. So I really like 18 just because it's been a while. Okay, I like 19 because this is kind of like a multiple choice question, but to do with hypothesis testing, which is so new for all of us. So a social worker claims that among all elementary school children, the mean time spent playing video games, which I'm just going through this now with Colin. I got out our old video game console last night, which I feel like is a mistake. Anyway, so playing video games each day is more than 2 hours. So determine if there's sufficient evidence to support this claim. And then I want to know which is the correct pair of my H naught and my HA. So you have to think it through before you just go through and read all your options, right? You should be picturing what it is that you're studying and what you're trying to prove and what your null is and what your HA is before you even look at your options. So I'm going to cover them up because I'm just going to think about it here. So I know that I'm dealing with this 2. What I do first is I write my HA first, and then I go up and I write my null. Okay, so my HA, I want to say that this person wants to show that the time spent playing video games each day is more than 2 hours. And it's a number, right? It's not a proportion. It's not a percentage, right? So it's numerical data. So this is mu. So it's my mu is greater than 2. And then my null is just the opposite. So I'm going to write mu is less than or equal to 2. All right. Or you could just write mu is equal to 2. It's the same thing. So I'm going to look through my options. I'm first going to look through my HAs because I need that. I mean, I need them both to match, but I'm going to look through my HAs first. So I'm looking for mu is greater than 2. So no, wait a second, please. So it's not A and it's not B because first of all, A is equals. You never have an equals in a alternative. So I know it's not that even just looking at that. I know it's not B because I have a proportion in there. P, that's not right. It's not C because that's mu does not equals 2. And it's not that. It says more than. So I know it's greater than. Again, D has proportions. I could throw that out. So then I could see E is mu is greater than 2. I know it's that one. It's my only option with the correct HA. So I know it's going to be that. And then I look at my null. It says mu is equal to 2. So there it is. Okay. I like that one. And then 20, we know that 34% of all RIT students are female. That's really low, isn't it? Recently, a researcher obtained a random sample of RIT students in which 50% were female. Which statement is correct? So you're looking down here and you're going to look at the options because you're kind of, when you read this question, you're not really sure what we're looking for, right? So A says P is 0.5 and P hat is 0.34. So, okay, it's looking for the population, and then it's looking for the sample. So it says we know that 34%. We know this up front. It's not a guessing game. We know it. So this is saying the population proportion of RIT students that are female is 34%. So I know that P equals 0.34. So when I look through here, there's only one option, which is C, but I want to make sure that the rest of it matches to make sure I'm right with my thinking here. Then it says that a sample, so that's my P hat, right? So it's proportions. It's either female or not, right? They either fit in the category or they don't, right? So it's 50%. So that means my P hat would be 0.5. This is a little bit of a tricky question, but I think it's good that it's on the review, okay? Because you might see a couple of tricky questions out there, and I don't want you to be surprised, okay? So it's C on that one. Any questions on the multiple choice? I'm going to just look at what I posted for the part 2 review, and I want to address anything on hypothesis testing. It's just the review sheet I have, like my date is from a year ago, to be honest, and I just feel like I don't know why it's so long ago. And I just want to make sure I have the same problem since I keep looking at my computer. Okay. The biggest thing that I've noticed with grading the hypothesis test, which you guys are really improving as teams, I've noticed, I'm hoping that everyone individually can do these as well, and they're not just relying on their teammates. It's hard for me at this point. I'm not with you a couple days a week, so I don't see, I'm not seeing individual work, so it's really hard for me to see who has it and who doesn't. But as teams, you guys are improving, and I think the biggest thing is telling if it's numerical or categorical, which that's what you should do before you even start the process. Writing, sometimes the null and the alternative I could see is tricky for some people, and it's not even the numbers, it's like you're just leaving little pieces of information out. And I feel like the calculations are all pretty good. I feel like that's like some of the biggest stuff and some of like the write-up. So I'm not going to go through the full write-up. You already have the solutions posted out here for you, so you can see what I have. I just want to talk about a few things. So on this part 2, problem 1, it's talking about that Pepsi-Cola company problem. When I'm looking through this, I didn't even read the question, but it just pops out to me that I see a percentage. It says 50%. Automatically, when I see something like that, I think proportions, but I want to make sure. Some questions look like proportions, but they're really numerical or vice versa. I try not to trick you guys with that until you get to stat 2, to be honest. But here, you know, it's just once in a while, so I just want to read through it and just make sure. So we're talking about cola preference right there. That makes me think proportions as well, because it's like, do you prefer Pepsi or not, right? It's like, yes, no. I don't know if that's what they're asking, but I'm just looking at this. So the Pepsi-Cola company would like to convince others that more than 50% of consumers prefer Pepsi. So it is. It's, do you prefer Pepsi? Yes or no, right? It's not that it's not talking about an average of anything, right? It's talking about a proportion. So if someone prefers it or not, that's proportions right there. When I'm looking at proportions, when I go down to my method step, my null and my alternative should include P, not mu. Mu is only for numerical, P is for proportions, okay? And it's not P hat, because P hat's not my unknown. I have P hat. It's 56 out of 100 is my P hat. So here, I'm just jumping right down to my method step. I'm going to go right to my alternative, my HA. So they want to show that it's more than 50%, right? So I want to show that P is greater than 0.5. Not greater than or equal to, and it's not mu, it's just P is greater than 0.5. Then my H naught or null, whatever you want to call it, has multiple names. My common view, whatever you want to say, is going to be exactly the opposite, or you could always write it as just a equals. So I always like to tell you guys to do exactly the opposite, and it's simpler, because if something's greater than, then you know the opposite is less than or equals, right? It just makes sense. So here my null is P is less than or equal to that same number, 0.5. The number does not change, it stays the same between the two. I'm just trying to mention some things that I've noticed popping up. Alpha should not be an issue. I don't want you to worry about it. I give you alpha. I will always say complete the full hypothesis test using like a 5% level of significance. It will always be 5 or 1%. You will rarely see it be some different number, right? But I will give it to you. It's not a guessing game. I don't want that to be something that stresses you guys out. Okay. So my goal goes with my HA. Like I don't even have to have all my other stuff, but the other stuff helps me. My goal is to show that more than 50%, right, of the population proportion of people prefer Pepsi over cola. Okay. Even on my write-up, I just say prefer Pepsi. Or over Coke, I should say. All right. So then all the other stuff just falls into place. But my 5-step process is to help you break it down instead of being overwhelmed by an entire process. It's supposed to help break it down for you. Any questions on that one, on any other parts? I just try to point out the stuff that seems to be tricky for people in general. And you know, guys, we have all week, so you could always ask me questions. You could always email me. We could do a video chat. You could just email me. We could go back and forth. If you have questions on things you don't want to ask, it's fine. But I just like to put that out there. Either way, you can ask now or later. Okay, so those are the main issues with the hypothesis testing. And then some people try to shorten it up. Don't shorten it up. When I want you to write something out, I want you to write it out completely. Don't shorten it by using like a mathematical statement. So in the goal, I don't want you to say that P is less than or greater than 0.5. I want you to write it out. I want you to say the population proportion of, like how you define P, is greater than or more than 50%. Like I want you to write that out for me. If you use 0.5, I'm fine with it. Or if you say 50%, that's all the same. But I want you to write it out. That's the point. Okay. And then I like problem 2. This gives us a lot of review for all the different types of probability type questions. So this is good, and I hope I have it on the solutions for you, but on mine, I have where I did the shading on the table, and I did the formula for you, for those of you that want to use that formula, okay? All right, so I'm gonna just go over part E because this is just something I see on here that's different, and that talks about mutually exclusive. Remember, mutually exclusive means no overlap. Okay, so two mutually exclusive events would be like and dislike, or like and uncertain, or dislike and uncertain, those kind of things. There's no overlap. They can't be because they're two columns, or it would be two rows, right? Northeast and southeast, or southeast and west, that kind of thing. So there's no overlap. That's mutually exclusive. They're disjoint. Okay, so that's how you tell that. Remember, independent meant that if you put a condition on a probability, it doesn't change that probability. That's what independent means. So it means when you look at just a probability alone, and then the probability with the condition placed on it, and if it still equals maybe 0.5, then they're independent, right? Because putting that condition doesn't change it. Okay, that's the independence part. I know that's the other part people have questions on sometimes. Okay, number 3, this is like a lot of data. And we'll try not to give you that much data. I will have to look to see because that can get kind of stressful putting that into your calculator. So on a problem like this, you're going to take the numbers, you're going to put them into a list on your calculator, and you're going to run the descriptive stats. That's something we learned like week 2 or 3 in the class. But we've been using it, so I'm hoping you still know how to do that. I don't have my, oh, I do have my calculator. I thought I didn't have it right here. So I'm going to put my information into my list where you could just go stat and then hit number 1, edit, and you can just enter your data. Then I'm going to quit that, and I'm going to go back into stat and then arrow over to calc, and I have the 1 variable stats right there. So I'm going to run my stats. Just make sure you're putting your numbers into the same list that you're going to tell your calculator to run the stats on that list. So you might just want to make a little note of that on some scrap paper when you do that. Remember, the mean on here is a sample mean, right? The mean is not the population mean, because here we're looking at a sample. So I will be clear with that. Like, I would be clear and say the following set of data is the sample of 64 unknown offenders, right? So I'm going to be very clear that it's a sample, but it's always a sample. If it was a population, there would be a lot of information there, okay? So it's always a sample. So we're always looking for X bar for my sample mean and SX for my sample standard deviation, right? So no, it's not sigma, that's population. So the mean, when you look at mu or X bar, it's the same calculation, so it's the same value. But when you look at the standard deviation, remember the calculation changes because I divide by n-1, okay? So we have to make sure that we use the correct standard deviation. That's what I'm going to look for on a question like this, right? I would look for that. So we have a box plot here. Obviously, I can't ask you to build a box plot for me because we don't really have a way of doing that. So I won't be asking you to build a box plot. But I may ask you to draw a box plot on your own paper and questions about a box plot. That could be reasonable. Remember how we get the outliers for a box plot? It's not anything just outside of like the IQR or anything like that. Remember, we have specific calculations for lower fence and upper fence. So you might want to brush up on that, how to calculate those. And remember that the whiskers on the box plot, that's the side parts, they only go to the number data value, I should say, inside the outlier, now inside the fences. So it doesn't go up to the fence unless the fence is a data value, which, I mean, it's happened, but it's not likely to happen. Okay. And remember here, again, I could tell the shape of my box plot, of my distribution, by looking at my box plot and comparing mean and median, right? So on part D, it says it's skewed right because the mean is greater than the median. Or I wrote here, the median is less than the mean. Okay, so that's how I can tell my shape, just by looking at a box plot with my mean and median. Or I don't even have to look at a box plot. I could look at my number summary above in part A. Any questions on that one? Okay. Problem 4, we have a CI here. I know it's a CI because part A says estimate the mean. Right there. That's it. As soon as I see the word estimate, I know it's a CI. That's your key. Okay. Estimate equals CI. That's it. So right there, I know I'm doing a CI. And it says mean. I know it's numerical data right from that. So the first 3 words, estimate the mean. I don't have to know what the problem's about. I know it's numerical, and I know I'm doing a CI. So it's like I could picture the problem already in my head without even knowing what it's about, what kind of numbers or anything. So I want to know, estimate the mean amount of cola in all servings from the machine with 95% confidence. So remember that 95% is what drives my t-value along with the sample size. So if I read the problem above, it gives me a sample mean of 8.7, a sample standard deviation of 0.49. So it gives me all those values, and it gives me an N of 61. So remember, this is a t-value because it's numerical data. We use Z for categorical. So in this kind of thing, you would have to use the table or your calculator. I will always provide the table. The table will be right under the page. It will be at the second page on your final exam. It will be right up front. So you all know it's there if you need it. You don't have to use the table if you can use your calculator. Remember, just some of us don't have the calculator function. So we might not be able to do it on our calculator. I have it on my 84 plus, but that doesn't mean that you have it on yours. Okay. So remember, my CI is point estimate plus or minus margin of error. My margin of error is my t-value times my standard error, which is s divided by square root of n. My point estimate is just x bar. So it comes out to be 8.7 plus or minus, and my t-value is 2 times my standard error, which is 0.49 divided by square root of 61. Okay. Below it, I just want you to point out what is the point estimate. Okay, so I'm going to say the point estimate to my x bar is 8.7, right? And then I might say, well, what is the margin of error? Like on this one, what is the margin of error? Margin of error is the whole second part of your CI. It's the whole part that you're going to add and subtract from the point estimate. So that should be 0.125 in this one. So that's my t times my standard error. Okay. And then the interpretation, nothing has changed there. When I ask you for an interpretation on a CI, there's a few things, like key things I look for. I look for the percentage. I look for you to say 95%, if that's what it is, or 99 if it's that. And I look for you to say population mean or population proportion. So I look for that, okay? I also look for the context of the problem. So like here, I have, we are 95% confident. I look for that. That the population mean, I look for that. Amount of cola served, that's my context. I look for that. So when I have those things I look for, that's how I deduct points. That's how I know what to take off, is between 8.5 and 8.8. Okay, so you know, normally in an exam I say 2 decimal places, and then some problems I'll ask you for 4 decimal places, but same thing here. And of course, I'm, you know, I lighten up about that a little bit. Okay, so then there's a follow-up questions, which we've already talked about for that. Question number 5 is a regression problem. So it's chapter 4. You have X and Y. You plug those into 2 different lists in your calculator, and then you go into the regression part, and you have to tell your calculator which one is X and which one is Y. So make sure you note that so you don't mistake. Part B, what is the correlation value? That's R, right? And then down in part E, it wants to know what is, let me see. It says write a sentence of interpretation for R squared. So R squared is just R actually being squared, but your calculator gives it to you. Remember, you need your diagnostics on for that problem. Okay. And I'll let you guys take a look at that and let me know if you have questions. Problem 6 is the empirical rule. Remember the percentages that I give you, like in questions. It would only be questions that pertain to the empirical rule. You shouldn't have to plug anything in your calculator other than like the amounts to get at the bottom. But like for percentage wise, I would only give you like 0.15 or maybe 2.5 where it adds the 0.15 and the 2.35. So I just want you to know that it's values that are given on the empirical rule, and percentages given there. I don't ask you for something odd. So if something is off, then that's probably on your side, unless I made a mistake, which I will double check and triple check. But something shouldn't be off. You shouldn't be guessing. You shouldn't be estimating or doing something weird, okay, with that problem. Number 7 is just another regression problem. Number 8 is another hypothesis test. Right here, I didn't even read the problem. I could just see it says 2 hours. I know hours is numerical. I know I'm studying mu right away, right off the bat on that one. And then number 9 looks like another one where I'm looking at box plots and I need to get like my summary statistics like we did on the other problem. So this gives you a really good overview. This actually gives you a really good overview from the new topic, hypothesis testing, and exam 1 and exam 2. All the solutions are posted. Feel free to email me, or if you want to do like a Zoom chat to go over anything, I'm more than willing to do that. So, just let me know if you have any questions at all. I am available. I will have a chat going on like I did for exam 2 in the discussion part, like the chat, I guess it's called, part on my courses. So then if you guys have any questions when you're in the exam, taking the exam, that I can answer those while you're doing that. Okay. All right. Well, if there's no questions, then we've hit our hour mark. And feel free to stop by and email me, or I say stop by, you can't stop by, email me, or ask me to do a Zoom chat if you have any other questions. All right. I hope you guys have a great day. I hope it's nicer where you are than it is here. It's raining here and it's cold. All right. All right, Amanda, thank you so much for captioning all this. I hope I didn't talk too fast today. Trying to get a lot in. Okay. Oh yeah, I forgot. That's it. All right. Thank you so much. I hope you have a good summer. Hopefully things start getting back to semi-normal. All right. Yeah, I know. It's so weird. Well, thank you so much. Have a good day, and I'll see you around, I'm sure, on campus. Thanks for all your help this semester. Yep. All right. Thank you. Bye.